Well, how are you doing? Okay, the title of this video will be The Lift Effect. Um, the lift effect is the absolute destruction of the globe Earth. Most people aren't aware of that. And when they're making arguments concerning the aircraft and aerospace, air travel, they look past the lift effect. And it's happened for years. Whereas they've talked about the nose of the airplane having to be above horizontal. This is due to the chord line of the wings having to be above horizontal. They they don't go into why it has to be, right? It's actually really simple, right? But before we get onto the lift effect, I must first address something here. So this is connected, obviously, this is directly connected to, I'm doing this for obviously reasons of this video. Here we have a blue circle, right? Now, let's say it's a sphere, right? Like the sphere Earth, right? We have orange tangent, purple tangent, green tangent, and red tangent plane, right? The 4 points on this sphere. Let's just call it, right? I know it's 2D, but we'll call it a sphere. So there's four tangent planes to 4 points. Now, each one of these have a right angle line coming from it. So you have four right. So you have 1, 2, 3, 4, 5, 6, 7, 8 right angles, right? Now, the thing about that is this: are any of these perpendicular? Most people would say it's a right angle, so it's perpendicular. But I'd be a bit more, I'd be a bit more traditional about it, and I would say no, there's no perpendicular here. Simply because a perpendicular is best described by a vertical and a horizontal making 90 degrees, right? That's what a perpendicular that if you want to get into its essence, that's what it is. They are right angles, but are they perpendiculars, right? This is the problem. If this is a sphere Earth, right, then which one of these, let's say the orange, the purple, the green, and the red tangent lines, which one of them is horizontal, right? Because to have a perpendicular, which would be a horizontal and a vertical, right, you need to have at least a horizontal, right? You can't just have a vertical to a tangent plane and just call that horizontal when the next, you can't do that on the surface of a sphere, because the next point on, let's say, see this little serrated, every one of these little serrated portions here, every one of them, right, they're all points. So the next point on will give you a different horizontal, right? So how is that horizontal? It's not. Horizontal is a constant. You can't change horizontal. You can't make this orange tangent horizontal and make this red tangent horizontal. They're obviously not. The red tangent is obviously a vertical, and the orange tangent is obviously a horizontal, right? In the real world, because we have reference to y. But if you're talking about a globe Earth, then none of them are horizontals, because you can't. Because I can put another point here and make it put a tangent plane there and put a line straight up from it, making two right angles, right? But none of them will be like, if you're talking about in within the the this, let's pardon the pun, sphere of thinking of a globe Earth, then there's no such thing as horizontal. It can't exist. You have tangents, but none of them can be horizontal because you don't have a reference. Where's your reference for horizontal? You don't have one. Your horizon, right, is not even horizontal because it's curved. You don't have a reference because at any point on that sphere you can put a tangent plane, right? So which one of those tangents, which of these four tangents are horizontal? Now in the real world, the orange and green are horizontals and are parallel to each other. And the red and purple lines are verticals and are parallel to each other in the real world. But in the world of a sphere, then none of these are horizontal. So because none of those tangents are horizontal, none of the lines meeting them at 90 degrees are verticals, right? They're making 90 degrees, but they're not really a perpendicular, are they? Because they're not. There's not one of these that is, if we're talking in the realm of a sphere and a sphere of belief, there's not one of these is perpendicular, right? So the point I'm making is that you don't have a reference for horizontal. Horizontal is not a temporary thing. So this orange line can't be horizontal now, and in a few years' time, this purple line be horizontal. It can't. That's just crazy, stupid nonsense, right? It's just stupid if that's what you think. If that's what you think, you either are going crazy or you're too stupid to understand what horizontal is. It's one or the other. I'm sorry, I don't mean to be insulting to people, but that's the way it has to be. There's the only explanation you can give is you have to choose one of those two. You're either crazy or stupid, because horizontal doesn't change. You can't change horizontal. All pitch is determined from horizontal. So how would you know what pitch of something is? The pitch of your aircraft. You'd never know what the pitch of the aircraft is, because your horizontal is always changing. So you'd have to constantly be changing your pitch because you're changing your horizontal. But what does pitch mean then? It means nothing. Pitch means nothing because you don't have a horizontal. You have something that you're claiming to be horizontal that keeps changing at every point, right? So it doesn't work. So horizontal, right, can't exist on the surface of a sphere. There is no such thing as a horizontal tangent in the realm of a sphere Earth, right? We could put a horizontal tangent onto a basketball on a table in the real world, but if we're talking about a sphere Earth, then a horizontal tangent doesn't exist because horizontal doesn't exist. So consequently, vertical doesn't exist because vertical can't exist without horizontal. Same way as horizontal can't exist without vertical. One requires the other, and one instantly creates the other. So none of these are perpendicular. They're all right angled, but technically they're not really perpendicular, are they? There's no vertical and horizontal on anywhere around this blue circle or blue sphere, if we're talking about the realms of a globe Earth. Now, that will become very obvious why I'm pointing this out, because what our opposition must claim is that horizontal changes. Horizontal is a local thing. It's crazy. Like, I mean, they can never give you a distance. They can never say horizontal is 10 miles, because then you can disprove that horizontal is more than 10 miles. They can never give you 100 miles because you can disprove horizontal is more than 100 miles. There's no distance to horizontal. Horizontal is just it is a constant. It's no set distance. It is infinite, right? If you could even speak about infinite in mathematically, it is about anything being infinite. Horizontal is infinite. It's an orientation. That's what it is. Vertical is another orientation, right? So there's two orientations. You can't change the orientation and then still think that you have a reference. You don't. How do you know that your starting tangent was in the first place? How do you know that that was horizontal if the next one is also horizontal and the next one is horizontal? If they're all horizontal, then none of them are horizontal. That's just, and none of the lines making a right angle to these tangents are verticals. They can't be. There's none of those are horizontal or vertical. Technically, within a sphere world, it's not. It doesn't exist. So because of that, I technically could just stop the video right now because I don't need to go any further. Technically, that ends it. The fact that horizontal and vertical do exist in real world and they are constants means that, and I just showed here they can't exist in the sphere world. That's the end of that. I don't need to go any further, but I will, because the lift effect requires detailing. So people understand it and can use it as an argument. It absolutely ends the globe. It ends it completely. Okay, here we have a diagram, right? Flight path, horizontal to ground, right? Tells you everything you need to know. You have a thrust, right, and drag. So thrust thrust opposes drag, right? That's what thrust does, right? So the more thrust, the less drag, right? But then you have lift, right? Lift opposes what? It opposes weight, right? So you must have adequate lift to oppose the weight of the aircraft. Now, aircraft are made of steel and all kinds of things, so they're pretty heavy, right? You find me an aircraft that's not heavy. Every aircraft has a certain amount of weight, and the only way to oppose that weight is through the gaining of the lift, through the lift effect, right? So if you don't have adequate lift, then you're not going to account for adequate weight. So what'll happen? You're going to fall out of the sky, right? You won't even take off if you can't generate enough lift. So without enough lift, right, you can't oppose the weight. Can't oppose the weight, you go down. That's the way it is, right? So how are you supposed to oppose the weight if you're not generating enough lift, right? This is the important thing, right? But and we'll move on from that now. Move on to the next one. But that's the most important part of this. Lift must oppose weight, keep that in your minds. That's the most important part. So move on to the next diagram. So horizontal flight path, low speed, horizontal flight path, high speed, right? Straight and level, low speed, straight and level, high speed. Level and horizontal are the same thing, right? Wow, who would have thought that? Um, Here you have at low speed the angle of attack, right? The pitch of the aircraft, right? Pitch is determined from horizontal. The pitch of the aircraft is high, right? At low speed. Here you have the pitch of the aircraft above horizontal again is not so high. It's a bit more shallow, but it still has to be above horizontal, right? Because the lift effect requires that the chord line of the wings is always above horizontal. So consequently, the nose of the airplane is always above horizontal. And the reason that the pilot has to fly like that, when a pilot is flying from A to B, right, we're not talking about acrobatics, we're talking about a plane that's traveling a distance from A to B, is the reason the pilot must have an above horizontal pitch is because without the above horizontal pitch, then there won't be enough lift to generate. There isn't going to be enough lift generated to oppose the weight of the plane, right? And that's the problem. Without enough lift, you can't oppose weight, so you fall out of the sky. But the only way to create the lift is to have an above horizontal, the thing that's a constant, that can't be changed, pitch, right? So we'll move on to the next one, right? Same thing, right? What relative wind here, right? Which is where this shows exactly where, let's say, the airflow, or when you're flying through the air, what part of the wing it's hitting, which is right here, right underneath the front edge of the wind of the wing. Right, but this line is what they're referencing here with these three lines is horizontal, right? Slow speed, you have a high angle of attack, right? You need a higher angle of attack at a slow speed to keep the same amount of lift, right? Right. At a cruise speed, you don't need as high of an angle of attack, right? But you still need to have an angle of attack to keep the same amount of lift to oppose the weight. And at a high speed, your angle of attack is shallow, but it's still above horizontal. So your angle of attack is always above horizontal. It can't not be, because without that, you can't generate enough lift to oppose the weight, right? So how are you going to fly from Denver to New York, let's just say, right? How are you going to do that if you're not opposing the weight? And the only way to oppose the weight is to have an above horizontal pitch angle, right? So all pitch is determined as degrees, right, above and below horizontal, right? So this pilot flying this can't be flying along, right, and then decide to change to a different horizontal. That means the whole plane's pitch has to completely change, right? It's crazy. That doesn't happen. That's not reality. That can't happen because the pilot has to always fly with above horizontal pitch. So how can he change horizontal and make horizontal down this direction? Can't do that. It's just stupid to even think that would even happen. Here we have again nose high level flight, right? Right. This is talking about the the chord of the wing of the chord line of the wing. Here you have nose high climbing, right? So this is the horizontal here underneath, and this is the pitch of the plane climbing up, nose down, descending. As you can see, this blue line here that is they're taking the pitch from is the horizontal, and when the plane's wings are below horizontal, it's a descent. The nose is also below horizontal. It's a descent. You can't fly around a sphere. It can't happen because once you're descending, you're not accounting for weight, right? You're not accounting for weight when this chord line here is not above this blue line. You're not accounting for weight, right? You have nose higher level flight, nose high descending, right? And nose level descending. What that is that the nose high is generating lift, but they're slowing down the plane, right? So consequently, you will start because thrust generates lift, right? The more thrust, the more lift. That's why the airspeed that you're flying at, the airspeed you're flying at determines how much pitch, right, you're going to have above horizontal, right, for lift. Because if you're flying at a fast speed, you won't need as much of a pitch above horizontal, but you still need a pitch. If you're flying at a slow speed, you will need a more of a pitch above horizontal. So that's how it is. So the pitch is determined by the airspeed. That's how it works. Uh, but if you're slowing down, you will be losing lift. So you can come in, you can descend by keeping horizontal. You can descend, but basically the plane is just starting to fall out of the sky, or you can descend slow by having a nose high descending, a slower descent with the nose high, right? Well, the point is that you're coming into land, you're going to have the nose up anyway, because you can't land like this, right? But you can descend like that. But you still got to reference horizontal. As you can see, the nose of the plane and the tail of the plane are directly, the line there through the plane is the horizontal, right? That's what you have to have. So once again, so right, this tail down force creates moment in opposite direction. So what happens is that as you pitch the chord line up, right, what happens is that the lift effect happens because of the air hitting this portion of the wing here, but that causes the tail to go down slightly, right? So it's a twofold thing that needs to be balanced by the pilot, right? Regardless if you're flying a huge plane or a little small Cessna type thing like this, you're going to need to deal with the same problem, right? So tail down, right? So when you pitch up, tail down, or tail down, pitch up, right? That's how it works. Here you have the stabilizers, vertical stabilizers and horizontal stabilizers. So this is what they use, the elevators, right? Sorry, vertical stabilizer and say elevator, yeah. The stabilizers here, I'm just going to focus on the horizontal stabilizers. They are what determines, this is how one of the ways a pilot will gain lift by the use of these, right? Will cause the downward, let's go back here, sorry, I didn't mean that happen, will cause this downward force on the tail, right? So by changing the elevator, right? So the wind, so the airflow from the wing, from the front of the plane to the back, pushes the tail down. That will bring the chord line of the wings up, right? That's one way a pilot can do it. Now also with thrust, you're generating lift anyway because there's a greater air pressure hitting underneath just underneath the front of the wing here, right? So either way, you're doing the same thing. You're using both of them to generate lift, right? But it's always, if you're going to be opposing the weight, you always have to have an above horizontal pitch. There's no way around it, right? That's what it does, right? So this is how they generate lift. So here we have horizontal again, right? Flight path, right? Flight path is in is in an upwards direction, right? So they're generating lift to oppose the weight, same thing, right? So this is a climb unaccelerated. And here we have a dive unaccelerated, right? Right. So once again, the pitch is below horizontal. So anything below horizontal is officially, I've shown it before, anything below horizontal is officially a descent, right? So how could this be a dive? How could this be a dive? How could this be a dive when technically, that's what has to happen over the surface of a sphere Earth, right? Besides the fact that horizontal doesn't exist, it has to be a constant over the surface of a sphere. There has to be a constant from the moment you reach cruising altitude. You must second by second have an accumulated below horizontal pitch. So you can never, on a globe Earth, if you do the mathematics, you can never have an above horizontal pitch. So consequently, you can't oppose the weight. The plane can't fly around the globe because it can't oppose the weight. It's impossible because you can't oppose weight if you don't have an above horizontal pitch. And if horizontal doesn't exist on a globe, right? Number one. And number two is whatever straight line you're trying to judge your pitch off of, you won't have a pitch above horizontal because you have to start having an accumulated below horizontal or below a straight line pitch, right? From the moment you reach cruising altitude. So from that very moment, you're going to be descending. There's no way around it. And in reality, that would mean a descent down to the earth. You're not going to stay in the air because you don't have a lift. You're not generating lift, so you can't oppose the weight. The only wing that will generate lift with a below horizontal pitch, the only one is a cambered wing, right? Now, the cambered wing will generate a certain amount of lift with a below horizontal pitch, up to about 5 degrees below horizontal. The cambered wing, though, at 2 degrees below horizontal, has a 60% positive, 40% negative lift, right? At 3 degrees, about a 50-50, right? 4 degrees, you're talking maybe 30% positive, 70% negative. And at 5 degrees, no. Basically, you'll be talking, if you're lucky, 10 degrees positive, 5 or 10 degrees positive lift. But let's go back to 2 degrees below horizontal. So a 2 degree below horizontal pitch, right, with a cambered wing, you will have 60% positive lift. Well, that sounds great, right? And some of our opposition might try and use the cambered wing as some kind of like, even though cambered wing is only something that's on some planes, like it's not on every plane. They try and use that as some kind of a BS argument. It's like, but what's opposing the other 40%? What's opposing that? What's opposing the other 40% of the weight? Because if you only have 60% of the if you only have 60% positive lift, then you're only opposing 60% of the weight of the plane. That leaves you with 40% unopposed. You take that 40% and you put it into a 787, a Boeing 787 Dreamliner. What have you got? You got a situation where you don't you're not opposing the weight. So what does that mean? That means you're going down. I mean, there's no way around it. The lift effect requires horizontal to exist, and it requires the pilot to fly with an above horizontal pitch to generate enough lift to oppose weight. And if they don't do that, they go down. It's that simple. And the only way to have that is for horizontal to exist. But horizontal doesn't exist on the globe. Here we have an unaccelerated vertical climb, and once again, they're referring 90 degrees, right? This is a vertical climb, so vertical, horizontal. Planes couldn't exist without vertical and horizontal existing, but they don't exist on a globe. They don't exist in that paradigm. So a plane can't. Not only would the pilot have to be constantly changing what he or she is calling horizontal, which would be crazy. You can't do that. Not only would they have to be doing that, but horizontal, but what they have to do, there's no point in it. It just doesn't work. Simple as, it just doesn't work. There's no point in trying to find out a way how they could. It just can't happen. It's just impossible. It can't work. It doesn't work. It won't work because the plane is just going to go down. They won't be able to have any positive lift. They can never have an above horizontal pitch to fly around the globe. So an 11-hour flight from London to Los Angeles, you will end up with, you'll have an is it 87 at 500, an average of 550 miles per hour. You'll end up on a globe 87 degrees below your starting horizontal. What lift are you going to have for that? None. It doesn't. There's no such thing. Lift won't exist in that paradigm because it can't. They don't even have a horizontal. That doesn't exist. Right. So here, yeah. How is any plane supposed to fly around this here when they need to have an above horizontal pitch at all times? So how is I'm just going to turn on the show grid. Maybe on my line. So right, how is a pilot supposed to fly in this direction with an above pitch above this orange line, but still fly around that? Can't. The pitch that the pilot will have on a commercial airliner will be +3 to +5 degrees on average throughout the flight. So the flight from London to Los Angeles, the plane will always be at +3 to +5 degrees at cruising altitude and cruising speed. That's what it'll be. They'll always have that pitch. So it's impossible, right, because of that, because they have to have that pitch to oppose the weight. So it's impossible to change that and still oppose the weight. You can't just decide later on that this orientation here is horizontal. It's not. Horizontal is one orientation. You can't change it. There's no such thing as a local horizontal. Horizontal is horizontal. It can't be changed. It's a constant. So this orange line, if this is the starting position of a pilot on a globe, and this is their starting position, when they take off, like, what's going to happen? They're going to be raising in altitude straight away. It just won't work. Not it won't work because you can't. You'd have to dip below this line to continue following around the surface of a sphere. The whole thing is just a complete mess. You can't do it. They won't have any lift as well once they go The lift can't even exist. Lift can't exist on a globe. It just can't exist because horizontal can't exist. So lift can't exist. It's just there's no way around that. I'm sorry, it just doesn't. It's not possible. So just to close out, just to show very quickly, although it's pretty already very evident. So here we have, right? So this is the kind of pitch, right, that a commercial airliner is going to have to keep. This is the horizontal, this purple line. This is the kind of pitch the commercial airliner is going to have to keep to hold positive lift through a flight. So for like 11 hours from London to Los Angeles, they're going to have to stay with a pitch above this purple line. Right, right. If they're flying fast, the pitch can be down here. If they're flying slow, the pitch will have to be up here. But the point is that they have to keep an above horizontal pitch, because as soon as they have a below horizontal pitch, they're not posing the weight of the plane. So this below horizontal pitch means that even with a cambered wing, the full weight of the plane is not being opposed. So what happens? It's going to go straight down. There's no way around it. It can't not go straight down. It's impossible. It's impossible for the lift effect to exist and us also live on a globe Earth in a heliocentric space. It's just impossible. It can't happen. Horizontal can't exist within that paradigm. The lift effect can't exist. Airplanes can't exist within that paradigm. So the next time someone wants to ask you about, give me a proof for a flat plane, for a flat Earth or a horizontal plane, you just point to the lift effect. To oppose the weight, which is weight is a down, to oppose the weight, right, to keep the plane up, they need to have an above horizontal pitch, and that requires horizontal to exist and horizontal to be a constant. That means it's always in the one orientation, unchanging, right? Now that's what we have in reality, but that's not what they have within a heliocentric paradigm, is it? So thanks for watching.